Hi everyone, welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, do let me know if I am clearly visible and audible to all of you or not. Yes, students? Thank you guys. I'm also so happy to see you guys here. So guys, my health is not fine. So the energy will be this much only, right? Because the doctor has advised me not to talk loudly. Plus, I have fever, so I won't be able to talk, like, have that much energy. But I didn't want to cancel the class. That's why I thought of starting the classes, right? Lecture won't be too long, so short lectures will be there, 1 hour, 1.5 hour, right? And that's how we are going to complete our coordination chemistry. Okay? Yes, everybody. Yes, Madhumati, Rama Raju, Sainath, Harshita, Abhi. So, shall we start the class? Right? New chapter we are starting. Till now, we have completed physical chemistry of class 12th. We have completed DNF block, and now we are at coordination chemistry. Right? Okay. So, let's start it. Right? And coordination chemistry is a very important chapter, right? Every single topic of this chapter is important. Today, I'll show you JEE 2024, 2025 questions. You will see for yourself how they are so important for you, right? Okay, let's start. But before that, I would love to tell you that MVSAT scholarship program that is totally free of cost. You can register yourself here, right? Offline test dates are 4th, which is not 4th, 5th, 11th, 12th October 2025. These are the offline test dates, right? You can visit your nearby center of Vedantu, right, and give the test. Registration is completely free and 100% scholarship along with iPhone, iPads, and full study material will be provided to you on the basis of the test results, right? Okay. So link is in the description box. You can see for yourself, right? Just give me a second. You can see this over here, right? Over here, MVSAT, register now. You will get to this portal, fill in your details and click on proceed, right? Okay, sure. Now, let's do this. Starting with the coordination chemistry, today we are going to discuss about 3-4 things. One is the basic idea, what are coordination compounds. Then we are going to discuss what is IUPAC naming, then what are the type or classification of ligands, then Werner's theory. This is going to be our full-on criteria. Okay, right? Yes, everybody. ठीक है जी चलो. Now let's start. First thing is type of salts. What are the types of salts that you have? So in chemistry, we have total 3 type of salts. One is simple salts. What are simple salts? That I'll tell you. Then there is double salts. Then there is complex salts. So one by one we will study this, right? Simple salts are like NaCl, Al2SO4, K2SO4. These are the simple salts, which on dissociation can be dissociated to individual ions. Okay, this can be dissociated to individual ions. they can be dissociated to individual ions. These are simple salts, right? Provide only a single simple cation and single simple cation. So only one type of cation and one type of anion. You will see here, right? Only one type of cation, only one type of anion is what you will see here, right? Now, next is double salts. So, double salts are when you mix two simple salts in equimolar ratio. Two simple salts in equimolar ratio. That is called double salt. Now let me teach you how. This KCl, it is 1:1. When you will when they will form a double salt like carnallite, this is 1 molar, this is 1. Cations will be two type of cations. One is K positive, one is Mg2 positive. Anions will be of two type, that is Cl negative. Anion is one type only here, that is Cl negative. Right? But salts are two different. Similarly here, 1:1, they will form potash alum, right? 1, if you see, this is 4. This is in the 1:4, right? This is 1:4. This is 1:4, right? This is how they are, right? So the question is, are these double salts or not? See, double salts are in the equimolar ratio. So non-equimolar ratio will not be the double salt. Next is stable. Now one very important thing is the properties of double salts, that they are stable in the solid states only, right? Broken down into individual constituents when dissolved in water. When you will dissolve it in water, they will be broken down into cations and anions, right? Then their solutions have same property as the mixture of individual compounds. So if you have, let's say, if you mix KCl and MgCl2, the mixture will have same properties as carnallite. Okay, so these are the properties of double salts. Beta, how a person will look when they have 101 fever and they have tonsils in their this area? How a person will look? Energetic. Okay, understood? You tell me, should I end the class if you don't want to study? I'm here to teach you, and you guys are, I don't know what you all are focusing on. If you don't want me to study, if you don't want me to teach, I'll just end the class. Okay? I'm literally not here for your this and that. So I'm sitting, you tell me if you want to study or not. Okay. Okay. Now, next is which of the following is the example of double salt? Now tell me which is in the equimolar. This is your JEE Means 2023 question. Can you see 2023 they are asking you these questions, okay? So tell me, which of the following are the examples of double salts? 1:1, 1:4, that is 1:1, that is 1:4. Tell me fast. Which of the following is the example of double salt? Equimolar ratio you should have. Don't worry, beta, I'll take rest. Okay, thank you, beta. Don't worry, I'll take rest. But right now, I just want to complete this particular topic so that something, you know, tomorrow I'll see if my health is not fine, then I'll cancel the class. But let's see. This is 1:1. This is 1:4. This is 1:1. This is 1:4. So answer will be this, and this A and C is coming out to be the correct answer. Which equimolar ratio? Equimolar ratio is what you have to see. Okay, that's why I showed you here that in these examples, this is not equimolar. This is not equimolar. Okay, so the examples where they have equimolar ratios are your double salts. Okay, now next is complex salt. Our today's full class will be based on the complex salts. Okay, in complex salts, what you have is coordination complexes. A full chapter we are going to study this, right? Here you have non-equimolar ratios. What kind of products you give, it is given. Like here CuSO4 and 4NH3 are non-equimolar ratio. It is 1:4. Can you see this is 1 and this is 4? So this is in 1:4, right? And this will form a coordination complex like this. This 1:4 non-equimolar complex is going to form this compound, right? Where, wait a minute, here it should be H2O and, right? This bracket, this metal here, and here you will have ligands. That is called coordination entity. And whatever is inside this coordination entity, on adding water, that will not be dissociated into the individual ions, right? Whatever is inside this coordination entity will not be dissociated into individual ions, right? So when you see this here, this particular compound is CuH2 twice. When this is dissociated in water, it will give you this coordination entity, because whatever is inside the bracket will not be dissociated. But in case of double salts, things were entirely different, right? In case of double salts, if you see, in case of these double salts, right, this is not a double salt, this is not a double salt, right? This is a complex. This will form a complex. These two are double salts. Okay. Now, if you see this here, when you dissociate this double salt, it will give you K positive, it will give you SO4, it will give you Al3 positive, right? When you dissociate this double salt, it will give you K positive, it will give you Cl, it will give you Mgd positive. So in double salt, all the things are dissociated into individual ions. In complexes, the ions that is inside the coordination bracket, inside this coordination bracket will not be dissociated. Okay, so that is how we differentiate double salt and complexes, right? Double salts are, how do you identify this? As I have told you here, this is in ratio 1:4. Okay, this is in equimolar ratio. This is in equimolar ratio. This is in 1:4. 1, this is 4. Okay. So double salts will be equimolar ratio, complexes will be non-equimolar ratio. Okay. Yeah, I'm not, frankly, I'm not completely all right. Okay. I'm just teaching you guys because I don't want to delay your syllabus. That's the only way I'm teaching. My health is absolutely not fine. I'm trying my best to be as normal as possible, as energetic as possible, but this is the maximum energy that I can show you. This is the maximum. Okay? Okay? I'm not even trying. I'm literally not even trying to make you feel that I'm not well. I'm trying like my best to, be as energetic as possible, but I'm not able to do that. Hanji. Thank you, Vita. Thank you. Okay. Now tell me if the difference in double salt, and I think I won't be able to complete today's full topics that I have mentioned. So I'll take only 30 minutes more. Okay. More than that, I won't be able to take. I'll try to take 1 hour class tomorrow as well, because more than 1 hour na, I can't stand. Okay. So 1 hour I'll just try, because I think instead of giving you full break, I would teach you slowly, but at least there will be no break. Okay. Now tell me, difference between double and complexes. Is that clear? Is that clear? What is the difference between double salt and complexes? Is that clear? If I want to write it here, if I want to write it here, how would I write? Simple salts, right? Simple salts are simple only, right? With just one cation and one anion. Double salts are two simple salts in equimolar ratio. Complexes are two salts, two simple salts in non equimolar ratio. Okay. Tell me, Vita, if these three things are clear, because I have shown you JEE 2023, they have asked question. Okay, right? हाँ जी, tell me beta if that is clear. Now let's understand the complexes, coordination complexes. Okay. Now, first is coordination entity, right? Coordination entity has a central metal atom fixed to a number of ions or molecules. This bracket is called coordination entity. Okay. Inside this, you will have a central metal atom and you will have ligand, ligand 1, ligand 2, ligand 3. This central metal atom is going to be electron acceptor. These ligands are going to be electron donor. Okay, this is going to be central metal atom. That is electron acceptor. Okay, now when you talk about an coordination entity, right, inside the bracket we have only two things always. One is central metal atom. It usually belongs to D block, right? It will belong to D block, right? Ligands are different types of ligands we have that we will discuss in detail, right? Then if you talk about an example of this, let's say this is an example, that is cobalt Cl3 NH3 thrice. Now out of this you have to identify which is a metal. Can you identify? I'm writing it here. Okay. Now I'm feeling like I did a mistake by joining the class. Do you understand that on YouTube we have not even taken a penny from you guys? I am not fined. In batch, I am teaching because that's my responsibility. Right? They have paid for it. But I am here not well for you guys, and all I can see is, again and again, same question. Why you're so dull? Why energy is so low? What happened, ma'am? Beta, I had typhoid plus viral, like, plus I had tonsils. That's why I'm not able to speak. I still have tonsils are swollen. I can't explain it every 5 minutes of the class. If you think that the vibe is so low, that is so dull, I'll just end the class. Okay, I'll just end the class. No point. I have taught in batch also yesterday, Sigma batch only. Everyone was so patient. But tell me, if you want me to teach, I'll teach. If you don't want, I'll go. What is this kind of behavior that you're flaunting? Yesterday, also, last class that I took before getting ill was your class, DNF block class. I was not well, still I took that class. And I regretted after that. Beta, how many times do I need to tell you? Huh? 20 minutes more, I won't be able to speak more than that, okay? Okay? Literally, my health is not fine. Yeah, 20 minutes more, then please focus on the class instead of, because it takes efforts to speak even one word. Okay? So, this is the coordination entity which is inside the bracket. If you see here, this is central metal atom. This is ligand, this is also ligand. These two are the ligands. Okay, these two are the ligands. This is the central metal atom. Right now, here it is surrounded by ammonia. This is ammonia molecule and 3 chloride ions. Right, these are the ligands. This is the metal. Now, if you talk about what is central metal atom, ma'am, what do you mean by that? It is the one which is bounded by ligands, right? The atom to a fixed number of ions or groups. That is ligands. Central metal atom is bounded to a fixed number of ligands in a complex, right? And it are bounded in a definite geometrical arrangement. That means it can have square planar arrangement, it can have octahedral arrangement. These two are very famous. This kind of arrangement, this kind of arrangement. So here you will have the metal and here you will have the ligands. So it is metal surrounded by the ligands in a coordination entity. Okay. Now, if you see what are the different central metal atoms here, if you see this complex here, this nickel is the atom, right? So this will define the metal and this will define the ligands. Okay. This will define the metal and this will define the ligands. Okay. This will define the metal, this will define the ligands, right? So now you will ask me, ma'am, how this is Ni2 positive, how this is CO3 positive, that I will tell you. For that, you need to have the knowledge of ligands. Then you will be able to find out the charge on the central metal atom. Okay? Now, these central metal ions are also referred to as Lewis acids. Why? Because central metal atoms are electron acceptors. And Lewis acids are also electron acceptors. Okay, that's why they are referred to as Lewis acids. Next is ligands. Ligands are electron donors, right? They want to donate the electron to the central metal atom, right? That's why here the arrow will be like this, because ligands are donating the electron. Okay, that's why arrow will be towards the metal, right? Now, there are so many ligands and we will also study classification of ligands, type of ligands, right? Ions or molecules that are bounded to the central metal atom in a coordination entity are called ligands, right? Maybe simple ions such as chloride, molecules such as water or ammonia, or it can be big molecules like this ethylene diamine. This is nothing but this is actually CH2, CH2, NH2, NH2. So it can be a single ion, it can be a simple molecule, it can be big molecules, right? It can be neutral, negative, positive, so many things can happen. Okay, right? Now, if you see this, talking about the ligand, we'll talk about the denticity, right? Denticity, usually students are confused about it. So I'll tell you what is denticity. It is a number of not liganding groups. That means number of donating sites in a ligand. What is the number of donating sites in a ligand is defined as the denticity. I'll explain you. It can be denticity can be 1, 2, 3, 4, and so on. So based on it, it is monodentate, that means denticity is 1. Bidentate, tridentate, tetradentate, hexadentate, pentadentate, heptadentate. Okay, so many examples are possible. So unidentate means it will have one donating site. Only one donating site it will have. That is called unidentate. So if you see this one donating site here, unidentate ligands, example can be, first is fluoride ion. It has only one donating site. Water, that is having only oxygen is the donating site, right? NH3, only nitrogen is the donating site here. Here this is the donating site, here this is the donating site, here this is the donating site. So only one donating site it has, right? So they are said to be unidentate. I'll also show you one table on this, right? Then if you see this here, fluoride, bromido, iodido, or iodide. I'll tell you how to name this in IUPAC nomenclature. Will know about the name. This will not, as a ligand, this is called aqua. This is called hydroxo. This is called iodido. This is called bromido. This is called chlorido. This is called fluorido. Okay? Understood? Yes, beta, I'm fine. Not that better, but okay. ठीक है? So these are the general name, but as a ligand, they have different IUPAC naming that we will talk about in nomenclature. Okay. Firstly, just remember that these all are unidentate ligands. They have only denticity 1. Ammonia has only nitrogen site. Carbon and oxygen. Here, oxygen will be the donating site. Here, carbon and nitrogen. This is very important. These two are important. Okay. I'll tell you why. But I'll tell you why. You can mark here important. I'll tell you why in the end of the class. Which is the donating site here? That I'll tell you after some time. Okay. Next is didentate. That means bidentate. Okay. Didentate means bidentate. Two donating sites. ठीक है? Very famous example is this CH2, CH2, NH2. This is also NH2. This and this are the two donating sites. Okay, so it will have two donating sites, right? So this is nothing but ethane 1,2-diamine. Ethane means nothing but CH3. CH3. When you replace 1 hydrogen with NH2, that becomes ethane 1,2-diamine. Two amines you have attached. Okay, it's a very, very famous example. Then another famous example is oxalate 2, which is oxalate. So this is nothing but COO negative and COO negative. Here two donating sites are this and this. These are the two donating sites in oxalate. As ligand, it is called as oxalate 2. I'll tell you why. Okay. Now, another examples are ethylene diamine. This we have already seen. CH2, CH2, NH2. These two are the donating sites here. Okay. These two are the donating sites here. Oxalate ion also we have seen. These two are the donating sites here. Right. What about this one? This is phenanthroline. Phenanthroline structure is important for your JEE preparation, right? Otherwise, most famous are these two, right? This you will see very rarely, but structure is important. They can ask you directly the structure. Okay. So here, this is donating site and this is the donating site. Okay. Right? So this is the donating side, this is the donating side. I think I was so much in energy when I used to teach you. Now you are feeling like, what has happened to ma'am? I don't know what has happened to me. Okay. Another donating site, two bidentate ligand. This nitrogen and nitrogen are two donating sites. It is 110 phenanthroline on 1 and 10 position. You have phenanthroline, orthophenan it is called, or salicylato. Here, this and this is the donating site, right? So all these are bidentate ligands, right? Then you have acetyl acetonato, ACAC. Here, this is the donating site and this is the donating site, right? Then you have 2,2-dipyridine. Here, nitrogen and nitrogen are the donating site. So, these are the factual questions. So, here they can ask you about this thing. They can ask you about this thing. What they will ask you is a simple, either ethylene diamine or oxalato or this acetyl acetonato. This is also very important, right? This they can ask you the structure. This is diphenyl, right? And here this position and this position are the basically in it is dipyridine. Two pyridines are attached here, right? So these two are the donating sites, right? This as it is in the complex, they can ask you structure. They can ask you for this one, for this one, for this one, and for this one, right? So these are your diphenyl. Now, 2023 question. 2023 question. Denticity of organic ligand by urate. Now for that you should know what kind of ligand that is. This is your latest question. Okay. So that's why they can directly ask you the denticity. So this is called biurate. Carbon C double bond O NH2. This is NH C double bond O NH2. Confusion can be, ma'am, this and this is actually the donating side. But in reality, you have this and this as the donating side. Because this, because of steric hindrance, it is not able to donate the electrons. So it is a bidentate ligand. It's a bidentate ligand. Okay. So answer will be, answer is, as you can see here, 2, 2. So two sides are this and this is the one molecule. This is another molecule where this and this are the donating side. So each molecule is bidentate. So answer will be 2. Okay, everyone. Yes. Sure. Next is definitions. Polydentate, more than 2 donating sites which has, right? That is called polydentate. Now, one by one, we'll talk about the examples, right? Now, I'll give you one example here. A minute. If you see this here, right? This particular thing, how many donating sites you have? This nitrogen, this nitrogen, this nitrogen. So it is 1, 2, 3. 1, 2, 3. Triethylene. Tetramine. It is actually not triethylene tetramine. Wait a minute. No, because this structure will have denticity 3. This structure is cyclic structure, right? So this is going to have denticity 3 because of this nitrogen, and this nitrogen. So denticity is going to be 3 here. And if you talk about EDTA, this is what they will ask. EDTA. EDTA compound is whatever is ethylene diamine, ethane, you had NH2, you had NH2. Now 2 hydrogens are replaced by CH3COH. Okay. Very important point I am telling you here. Usually students cram this thing that EDT is hexadentate, but it's not always the case, right? Here, this is ethylene diamine, 1,2-diamine, tetra, Sc, acetate. It's not acetate, it's acetic acid, right? So, why this is EDTA with 0 charge? Here the donating sites are this and this. So, it is actually, denticity here is 2. 2 donating sites it has, right? But now what I'll do, I'll copy paste this. How many times? 4, 5. Okay. Now what I'll do, I'll replace 1 hydrogen here. It will become acetate. Acetate. Ion. Right? But out of this only 1 is your O negative. So now it has 3 donating sites. Denticity will be 3. Okay. Next is I'll replace 2 hydrogens. Now, if you see this here, it was -1. Okay. If you replace 2 here, it will be this and this also. Now denticity is going to be 4. It is going to be EDTA 2 negative. You replace 3 hydrogens. This will become negative, negative, negative. Now you will have 1, 2, 3, 4, 5 donating sites. So EDTA 3 negative is pentadentate. Now the one that you usually study, O negative, 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 1, 2, 3, 4, 5, 6. This is actually hexadentate. EDTA 4 negative. Okay. Okay. Yes, everybody, tell me if that is clear. Tell me if that is clear, right? So based on this, like here you have, if you see this one, it's a very, very interesting concept, okay? Diethylene, 2-ethylene you have, that's why it is first ethylene, this is the second ethylene. Diethylene, 2-ethylene, and this is triamine, that means 1, 2, 3 triamine, okay? Here, how many nitrogens you have? 1, 2, 3, right? So here, but in this case, the denticity is not going to be 3. Okay? Denticity is not going to be 3. As you can see here, this is your JEE mains concept. Wait a minute, let me just show you that. Right? No, that was because of C double bond. Here you don't have that. Wait a minute. Here it will be 3. I'll tell you why. If you have C double bond O, NH2, this is NH, this is C double bond O, NH2. Here what will happen, right? When it is donating from this side and this side, donating from this side becomes very difficult because there is gap of just 1 carbon. That's why here it will not donate, right? That's why here denticity was 2. Because in this case, understood now one thing, C double bond O, this is NH2. It is on the alternate positions. From alternate positions to donate the electron, it's very tough, right? I'll tell you why. Because there is a concept called ring formation, right? So ring formation here will be very unstable. Chelate effect that we call. We'll study that. Now, ring formation is very small here, which is very unstable here. That is the reason, right? That is the reason this nitrogen will not donate the electron. But here you have this will donate, this will donate, this will donate. Now, if this also donates, there is a gap of 2 carbon. There is a gap of 2 carbon. So that's why all the 3 nitrogens will donate. Better tell me if that is clear. Okay. Now, let's see this. Acha. One more thing. If I ask you to draw This is diethyl. Na? If you have to draw triethyl, tetramine. I'm just trying to tell you how to draw these structures. It's not that difficult, right? Triethyl. Three ethyls. 1, 2, 3. Okay. Tetramine means 1, 2, NH, 3, and this will be the fourth. Okay. If you see this here, 1 nitrogen, this will donate, this will donate, this will donate, this will donate. Okay. Here denticity is 4. If they ask you to draw tetraethyl pentamine, one more nitrogen will be there. So it will be pentadentate. Okay, got it? Now this thing you see, nitrilo triacetato. 3 acetato you have. 1, 2, 3, and this is the fourth donating site. So denticity is here 4. 4 donating sites you have. Okay. Now 2 more things we are going to do, then I am going to end the class. That is chelate effect. As I told you, whenever there is ring formation because of donation, that is called chelate effect, right? Uses 2 or more donor atoms simultaneously to bind a single metal atom, that is called chelate effect. Let me tell you how. This is metal. Let's say this is ethylene diol. Okay. It will be if you see this here, I'll just draw it like this. This is ethylene diol. Okay. This is the metal. It is donating. It is donating. Can you see a formation of 1, 2, 3, 4, 5 membered ring? This is called chelate effect. When from one single molecule to one single metal atom, 2 or more than 2 sites are donating, and because of that there is formation of a ring, that is called chelate effect. More stable is the ring, more will be the chelation, right? So these all are forming the ring, right? Here it is forming the ring, 5 membered ring. Here it is oxalato is also forming 5 membered ring. Here this acetyl acetonate is also forming one ring, 6 membered ring, which is very stable, right? Diethylene tetramine is also forming 2 kind of rings. This particular set is forming 1, 2, 3, 4, 5 membered ring here and 5 membered ring here. Now, if you're not able to understand this part, see. Diethylene triamine. Na? Where should I write it? Where should I draw it? Diethylene triamine I am drawing here, okay? Diethylene was nothing. You can draw it like this. Diethylene. Two ethylene you had. This is NH2. You can also draw it like this. This is the metal. Instead of doing this, you can draw it like this. Let's say this is the metal. Now what will happen? It will give donation from this side, and from this side. So 1, 2, 3, 4, 5-membered ring will be this side. 1, 2, 3, 4, 5-membered ring will be this side. So this kind of ligand is forming two rings with one metal, right? More the rings, more is the stability, right? So it will be more stable, right? When di or polydentate ligand uses two or more donators simultaneously, it is said to be treated ligand. This we have already done. Then the last part of today's class is ambidentate ligands. They also have two donating sites. But why they are not called bidentate? In a bidentate ligand, you have two metals. You have two donating sites, and both the donating sites it is donating at one particular point. Like ethylene diene. You had ethylene diene, right? It had two donating sites, and both the donating sites are donating at one point, right? But ambidentate ligand has two donating sites, out of which only one is donating at one point. Like this has nitrogen and oxygen. Sometimes nitrogen will donate, sometimes oxygen will donate. This has carbon and nitrogen. Sometimes carbon will donate, sometimes nitrogen will donate. Okay, that is called ambidentate. So denticity is one only, because at one point only one atom is donating, right? Sometimes nitrogen is donating, sometimes oxygen is donating, right? Sometimes here also, sometimes you will see carbon is donating, sometimes you will see nitrogen is donating. So that is the difference here, right? Okay. Here also, if you see this here, right, sometimes oxygens are donating, sometimes sulfur are donating, right? Again, ambidentate. Sometimes here sulfur is donating, sorry, here nitrogen is donating, sometimes sulfur is donating. If you see this here, wait a minute. It has actually three. Sometimes nitrogen is donating, sometimes sulfur is donating, sometimes oxygen is donating. So again, at one point, only one will donate, right? Okay, so these are the different examples of ambidentate ligand. Now this is a question, that is the set which does not have ambidentate ligand. Thank you so much, Abhijit. Thank you. Set does not have ambidentate ligand. JEE 2023 question. If you can see here, which does not have ambidentate, does not have ambidentate ligand. B, because see, NO2 is ambidentate here. Here NO2, NCS, these are ambidentate. Here also NCS is ambidentate. This is a set where not even one ligand is ambidentate. All are these two are bidentate. This is monodentate. So answer will be B is the correct answer. Okay, sure. Beta, other things we'll do in the next class, right? Because my health is not fine, so I won't be able to teach more than this. ठीक है? चल. Okay. And wait a minute. And I'll just show you one more thing because yes, tomorrow is what? Guys, tomorrow what we have? 15th August, Independence Day. So for Independence Day, what is going on? Freedom sale is going on, right? I'll just show you. If you see, Sigma batch was at 7,999, and can you see right now it is just at 1,499, right? So 79% off is going on Vedantu's courses, right? That is our freedom sale. And this freedom sale, guys, it is live till only it is valid till what time? It is valid only till 17th of August. Already students have enrolled. 2 more days we have, and the sale will end. Right? Okay? And this is going to start. Those who are asking me, ma'am, when the Sigma batch is going to start. So 20th August 2025, this is going to start. Right? Here you have 46% off, but at purely Sigma batch, you have 79% off. Right? Okay? Sure. So, Ram Chaitanya, don't worry, we are going to start organic soon. I'm just waiting for my health to be fine and I'll start with organic, right? Okay? Chal. Okay then beta, now I'll go, and happy Independence Day to all of you, right? Tomorrow is a very important day for our, India, right? And celebrate it, enjoy it, and for your, and also tell me in the comment section, what do you mean by freedom? For you, what is freedom? What, in pure sense, what you feel is freedom, right? Chal. Okay then, beta. Bye bye. Take care. See you all in the next class. Bye bye.